So as I said, my name is Jim Browning. I'm chair of electrical and computer engineering. And what I want to do today is give you an overview of the department, the field, and then a little bit about our department specifically. So electrical and computer engineering is a very broad field. It covers a large range of areas. It's one of the largest, most diverse engineering fields. I will talk a little bit about that, kind of an overview. Our graduates work in a number of different industries. We'll go over that a little bit as well. And they're generally in very high demand. Our graduates almost always work in their field. That is to say, they work in the electrical computer engineering field of expertise once they have their degree. So let's give an overview. This is just a very general overview. There are a lot of sub areas and other areas that are not included here. It kind of depends what you end up trying to do, but electrical engineers work in the power area with smart grids, alternative energy systems, work in the robotics area, and that includes embedded hardware, sensors, control systems. The electrical engineers, computer engineers work in biomedical area, instrumentation, medical devices, process imaging. And of course, one of the big areas is digital wireless communication, all of the things we're doing now with our satellites and our computer communications, smartphones, etc. There are a large number of engineers that work around the world in semiconductor devices and electronic systems. That can be making the semiconductor devices, that can be putting in hardware, electronic systems in autonomous vehicles, avionics, image sensors, such as the cameras that we're using right now. The computer hardware and programming is another very broad area. It includes both the embedded and hardware level at the microprocessors, microcontrollers, sensors, etc. And of course, another very large area is security and cyber physical systems. That's a very large growing area of electrical and computer engineering. So one of the big areas is the power grid. The power systems that control everything from the factories to your home. From the electrical engineering side, that includes generation, transmission, distribution of that electrical power, the motors, generators, transformers that support all of that, power supply design, that includes the electronics, power electronics, etc., that work in that industry, and of course smart grids themselves. As you know, there's a big interest in, particularly with alternative energy and the generation transmission of alternative energy, you need a smart grid system that can keep the grid stable as power systems fluctuate in and out during operation on a daily basis. Robotics, again, that's a big area. This includes the hardware and the firmware needed in the electronic systems. So if you take any robot apart, of course, you're going to find sensors, the microprocessors, microcontrollers, embedded hardware, the sensor communication, any wireless communication that goes on for that, image processing like the image sensors, LiDAR, things of that nature that communicate where the robot is or process information from those robots. And then of course the power systems and motors that make those robots possible. And you can of course expand robotics into autonomous vehicles or industrial machinery, industrial hardware, and what they call advanced manufacturing. All that's necessary. The biomedical engineering standpoint includes, for example, one of the big areas is imaging. So the hardware that creates, say, the x-rays and detects the x-rays and processes the image from the x-rays and then deploys it in an electronic format, a digital format, or MRIs, CT scans, etc. All the medical diagnostic and sensors. So you can see a picture here on the right, you know, with all of the hardware that's used in a medical setting to provide instrumentation, measurements, therapy, etc. And of course, one of the others would be the, you know, artificial limbs, which is also part of the robotic systems. The communication systems that we use are cellular networks, the fiber optic lines, what we call wired and wireless communication. So depending on how your particular home system works, you may be doing wireless, you may be doing wired. You certainly your cell phone and the cellular network, excuse me, is part of that smartphone system or your communication system. Satellite communication, if you have satellite TV, that's all part of it. Data compression. So one of the big things is the mechanisms by which the information coming over my camera is compressed down into a small enough packet that it can be transmitted wirelessly or wired through our system and then reconfigured once it gets to the other end. This is a huge area of electrical engineering, computer engineering to do that. Of course, transportation, that's a growing field as autonomous vehicles or other vehicle transmission, transportation, control systems are being put in place over the next several decades. Electronics, I mean, that's an enormous field. You know, here we can look at a smartphone or a computer system. If you look through your smartphone, for example, you have the display that goes in it, the antenna, the microprocessors and controllers, the power supplies, the communication ports, the oscillators and modulation systems that make all of that possible. And that's all fields that are require electrical and computer engineers. There are quite a few consumer products and industrial systems that use this type of electronics. We're very dependent upon it, obviously, today, and that also includes avionics and automotive systems. So there's a lot of overlap as well. So let's talk a little bit about the Electrical and Computer Engineering Department of Boise State. We have about 320 undergraduates and 18 faculty. In our curriculum, we require 5 hands-on lab courses. As well as what we call senior design. So all accredited engineering programs, such as ours, have to have a culminating senior course activity where you try to put everything together. And that for us is a 2-semester sequence in your senior year. But in addition to that, we have 5 what we call hands-on labs. So we have 2 circuits microelectronics lab courses, and we have 2 digital and microprocessor lab courses. And so every student takes those lab courses, goes into the lab and works on these projects along the way as you take your courses. You can see the photograph on the right of some of our students working in our electronics lab with the oscilloscopes, power supplies, function generators, these types of things, and their breadboard that they're working on there, and they're learning how to use all of that. Our department requires 126 credits. Of that, 18 credits are elective courses. So we allow 6 elective courses, and this is to allow you to emphasize in a specific area. 2 of those elective courses are what we call technical electives. They could be taken in computer science or math or physics or mechanical engineering. The other 4 are electrical engineering electives, and we offer a very wide range of elective courses in our department. 20 undergraduate elective courses are typically offered each year to cover that wide range of topics I was just talking about. Student support. Within our department, our courses are taught almost exclusively by faculty or industry representatives. So we get people from industry who have expertise in a particular field, and they will come in and teach a course or courses for us, depending on the course and the expertise. Within our department, we offer what we call peer training with labs. So you saw those students working in the lab. So we offer someone who has training experience. So they're a student who has lots of experience, as I was saying, an electronics technician, and they've worked a lot with that equipment. And they're available to provide one-on-one training with our students as they work their way through the lab, so they get more experience with the lab instrumentation, feel more comfortable with it. We also offer multiple tutoring and study sessions each week for example, our circuits sequence and our microprocessor digital sequence, as well as other courses where we offer study sessions during the week or tutoring sessions during the week for students to come in addition to our normal office hours and so forth. We have a dedicated department academic advisor, Christina Martin, who's on, as I said, is on this presentation, and she provides a lot of the advice to students. She will start with you as a summer, when you first come to the program and do summer orientation. Christina will help you set up your freshman year, and then she will continue to meet with you throughout your academic career, providing guidance and input on what courses you should take, when you should take them, and also, if you're interested in a particular area, a sub-discipline of the field, she can direct you to an academic, so for example, a faculty member who has an expertise in that field, and they can give you additional input. We offer a relatively new activity at Boise State. These are called certificates. So certificates are something you get along the way when you get your Bachelor of Science degree. It provides an emphasis area that you can put on your uh, transcripts, so that if you go to an employer, you can say, I have this expertise. One of the first certificates we set up were what are called cyber physical security certificates. So there are 4 certificates, one with an emphasis in software, one with an emphasis in hardware and embedded systems, one with an emphasis in industrial control, and one with an emphasis in power systems. We are just finishing our 2nd year of offering those certificates. They require 1 course that's all the students who want the certificate must take. And then you take 3 additional courses depending on your area of emphasis. We're also going to stand up a new certificate in biomedical engineering, and that certificate will start this coming fall and has already been approved. We are planning to start a new Bachelor of Science degree in what's called Computer Systems Engineering. It's been proposed to the State Board of Education. We're still waiting for approval, and we have planned to start that in the fall of 2021. Part of whether or not it starts will depend on the State Board's decisions, given that everything that's happening right now with the activities and whether or not they feel they want to get to this and approve it for us. But if you're coming in as a freshman, say in 2021, even if it doesn't start in the fall of 2021, it very likely will start in the fall of 2022. That system has an emphasis in computer systems, the hardware and embedded programming and firmware programming, with a systems emphasis and a cyber physical security emphasis. Our students have a number of different opportunities. These include internships, working with local industry. We get students who work internships in their summer, and some of them even including their internships over the academic year. We also, as a department and college, offer quite a few opportunities in what we call undergraduate research. These are paid positions in which students work in a faculty's lab doing research. And this can be anything from designing hardware, building hardware, testing, or running the actual experiments. There on the left, you see a picture of one of my students who has worked in my laboratory. And in fact, she was working in one of my other projects, other opportunities, which is called a vertically integrated project. So vertically integrated projects are courses. You can take this course, say, for example, in electrical engineering, you take this course for a technical elective. And that you take it for 3 credits, say 1 credit in the fall, 2 credits in the spring, and that course is all about research, how to do research, how to be trained in the research, how to prepare presentations, write papers, proposals, etc. For example, the students will give poster sessions and things of that nature. And so there's multiple opportunities in vertically integrated projects. I'm just mentioning mine, but we have probably 15 VIP type courses across the university and a number of them within the college, and new ones are starting every year. As a student, you can join the Institute of Electrical and Electronic Engineers. IEEE is the largest professional organization in the world, and students could join as student members, and that gives them access to the seminars and activities, including tours of local industry, etc., during their academic career. The activities and opportunities in our department are varied, and I don't want to spend like 30, 45 minutes going over everything because I know you're all busy. If you have any questions, you can email me, Jim Browning at boisestate.edu, or Christina Martin at boisestate.edu. We are happy to answer any questions. I have additional information if you want to know about where our students go for jobs and things of that nature. But I want to give you all to ask opportunity to ask the questions you're primarily interested in. You can do that by chat, or you can turn on your audio and ask questions that way. So thank you. What questions do we have? If you have any chat questions, you can scroll down to the bottom of the screen and you can see chat. Otherwise, you should be able to toggle your audio on and off over in the lower left corner and ask your questions. Okay. If you're interested, since no one's asking any questions at this point, I can show you some additional information about our program. Um, so here you can see something about our alumni. As you can see, about 70% of our alumni reside in the Boise area. 80% of them work in the field. That 19% that don't work in the field, you need to be a little careful about those numbers because sometimes that means they're a manager if they've been a graduate long enough. And so the data that does this analysis doesn't always pick that information out. But you can see we have people all over the country, but most of the people work in this field. If you look at the companies they work for, you can see, not surprising, the largest employer of our graduates is Micron Technology. We have over 100 graduates that work there, but you can also see companies like Idaho Power and Power Engineers. And when it says Boise State University, that means they're going to graduate school at Boise State. So that's one of the other areas. Again, any questions from anyone?
I'm also happy to talk about any degree requirement questions you might have. Specifically, I know with a lot of incoming freshmen, they have concerns about where they place in math. I'm super happy to answer any of those questions that you might have on the classes side of it. You can use the chat feature down at the bottom, or you can also unmute your mic and ask.